that I want to give, and this is gonna be very short introduction, and then we're gonna code something with what we learned. And the first of all, it was gonna be about I/O. So if we don't put anything inside, we can't expect to get anything outside. Okay, so let's start. First thing is gonna be, I think the most.
Make the browser full screen.
No, I tried. Like for some reason, it gets confused by the different resolution, and so it will try to expand as the resolution of this guy. And I can try to give it a bit bigger, and then to high toolbar. Huh? 20% improvement. Good. Yeah. So these are the modules that we will see today, and most of the most important part of them. I think the most important interface that Go has are these two, reader and writer. And then we have various combinations of reader and writer that is simply embedding the two interface previously. It's important because, as you see, we have many structures that implement this interface. You have a OS file, you have a buff.io writer and string reader, but many more implement the interface.
Is there someone here who doesn't know about interface?
Interface?
As in an abstract class, basically.
Right. In Go are a bit different. The idea is that interface, any structure that has a set of methods required by an interface, implement the interface. Okay. So basically, you don't have to actually say implements interface A. As long as you have the method write with that particular signature, you are implementing the interface.
Duck typing, something like that. It's static, so the compiler will check it at compile time. And if you're trying to pass an object that doesn't implement the whole interface, the compiler will say no, it's not doing that. So it's stronger than that, but you don't need to declare that you actually implement it.
And what we saw here,
when you pass a type that implements an interface, it's implicitly converted into that interface. You can think of an interface value like an object of sorts. So you pass a file, the compiler at compile time sees you're passing a file, converts it to an io.reader or whatever, and then anything can use the read method and look up what exactly which methods call for that type.
And you can also extend the interfaces. Let's say you want this reader and writer is an interface that implements both reader and writer. So to have an object that is a reader and writer, you have to implement both of these two methods, read and write, for your particular structure. So your structure can be whatever, like your own my class, my structure, and then as long as then you provide my structure write and my structure read, you are implementing the interface, and then you can pass it around wherever, any method that requires a reader or writer interface. Okay. This is the basic of how to open a file and then check for errors and then close it. Notice the defer. Defer is a special keyword in Go and allows you to defer the execution of that method or that function whenever the function exits from its normal stream of execution. This is a nice thing that this program that I'm using here, by the way, is made by the Google guys, and it's written in Go, and allows you to create a presentation very easily, and allows you. This is actually a Go file, and I specify, give me this range of lines, embed it, and then I can. When I click this,
What is this called?
this is called present.
Present.
Present, yeah. And when I do run, it actually compiles, run it, and gets the output and sends it back as a. It's pretty cool. Okay. Here you see we are already starting using the read method of the file descriptor. And one other nice utility that I saw is OS get page size. This usually is a good buffer size for doing your operation. Let's read this is the return error. Here and make I'm allocating an array of OS get page of the page size, creating a buffer. Read the content of the file in the buffer until it completes, and then if until I finish to read the buffer, I count how many bytes are in that buffer.
So if you don't know, Go for loops actually do everything from for to while to do.
This is a while loop, even if it's it is a for. Okay, this is for condition and body. Okay, but this is something that you will do over and over, so you don't have to write it over and over. There is inside the IO util, there is this method read file that actually will, from a file name, will give you back a whole stream of bytes of the contents of the file. Same way you have a write file. The catch is you don't need while in this example you need to check if a read error is not equal nil, but can be an error IO end of file. Okay, so you have to check, and it's not actually an error; it's just a flag. With this method, you have just to check if the error is not nil. End of file is already taken care for you.
I actually have a question.
Yes.
Could you go back one second? I'm very new to Go. In fact, I've actually not seen Go code until now.
Okay.
So is it common in Go to be returning like the result and an error as just sort of a
yes
an array?
There's a lot of philosophy and discussion about that. There's something which is like exceptions, which is called panic and recovery, but it's usually not used. Like most of the common cases are returning an error code. It's the last parameter. I use that. And you can read that they have a whole section in the FAQ about why is that.
So it's almost they're always throwing something.
Usually, most of the method that can have an error will return the return value plus an error at the end, and you need explicitly to check for the error. There is something called panic, which you can use, but it's really used for panic stuff.
Rule number one is don't panic.
Yeah, exactly.
And one of the cool things you can do with the documentation system is if you were to click on that link and go to see IOUtils read file, and then you were to click on read file again on that page, it will bring you directly to the source code, and it's like a couple line file that tells you, oh, this present actually does that.
Yeah, yeah.
Nice.
Yeah, well, that's
It's just a browser.
Yeah.
this is a browser, so.
Oh, okay.
How do I go back?
So, and then you can read a lot of functions in Go are easily understandable. You can just read them. Cool. Just figure out how they work. Like if you didn't know, apparently read file checks to make sure that the size is not above 1E9 bytes.
So let's look at
it
that.
Doesn't allocate too much.
Let's look at that. So I'm gonna go on the link. This is just a link from the presentation. This is the official Google documentation. I click on the name itself, in the blue one, and this will make us jump on the actual code. I will increase the font just to be a bit more readable. Okay, so let's break it down what it does, this one. It does the open file, as we saw before. It checks for the error, otherwise returns an empty buffer, otherwise, and the error on the side. It will, at this point, the error is not null, so it's a valid file descriptor, and we'll say, okay, when I exit from this specific function, execute this function. And this is good because so you have your scope of what you're doing. You don't forget. If it was all the way down here, you will already forget to close, and there will be some nasty go-to like we see in C.
Yeah. In C++, people implement something like differ with the classes that have the logic in the destructor. They just allocate it on the stack, so they know it's going to be done.
Okay, so the defer close allocates a variable called n of type int64, executes stat on the file descriptor, and if the error is nil, it tries to guess the size of the file, and only if the size is not too big, because you can open a terabyte of file and it will crash your machine. And then it will do a lower level operation like read all on the file descriptor. Now you notice that this method is lowercase. That means in Go that is not being exported. You will not be able to do ioutil dot lower read all. Okay, and also if we check, there is no read all lowercase, only the uppercase. Okay, any question here? Okay, let's switch back. Okay, read file and write file. These are inside io-ioutil, and you have to import like this on your program to actually use them. But then you will use only ioutil dot read file or write file.
I like the name closure gave this function, which is split and slurp.
Say it again?
Split, so write it to a file and slurp.
So inside the ioutil there is one variable that can be handy, and this is ioutil.discard. And what this is a structure that implements the write method, but it doesn't write anything.
It's a dev null.
So it's a dev null operation. Okay, and we can go. Oh, I missed the. Oh, it doesn't have here. Discard IO writer equal dev null, and if we go and see dev null, you see how they implemented here.
Line 123 is there. It's actually just an integer.
Okay, so dev null is a structure that's just an integer, right? Like this, but it doesn't implement write. Okay.
And part of what write does is you always return the amount that you have successfully written and an error. So in this case, it's lying and saying it successfully wrote everything, and saying nil is the error.
It's not lying.
And here actually executes the loop, otherwise it will not consume the buffer. Okay, you can just say write and not do anything, because you have to say the interface expects that the write method returns the number of bytes that you read from the I/O reader, and then raise an error or not if it's not.
Read from allows you to, would empty a reader faster than just doing an IO.copy from whatever your reader is to this writer.
So it's an optimization method, and it's only used internally by the.
It's used internally by IO.copy actually. I don't know what else uses it.
Okay.
At some point, I've read through all of these functions.
Yeah, there is.
Go, you can create methods on the objects directly.
Yes. On any type, you can add objects to it, methods to them. So you can.
Right, but where does it go to?
Let's say.
Like, there's a meta class that it's writing to. I'm assuming.
So we can do something.
A singleton class of that object that isn't elsewhere.
No, it's just a set of methods that's defined with this type.
Could you go back to the documentation or the source code?
Yeah, that's what he's writing right now. The playground.
This is the
No.
This is the playground. It's a web service that actually you can write code and play without this set. So we can do in this case. I have.
It's not typed out. You're doing C's.
Also, technically, it's not a class either.
No, it's just state, right? Object-oriented has been a bit overloaded, but at the end, what we are talking about is like state and a function that operates on this state. And state is usually memory, right? Bunch of bytes somewhere that you want to modify and act upon it. So here is basically we are saying in this state we want to change. Okay. And here basically now we have to do instantiate the type. And now example. See if it parse.
Change it to print out.
Yeah.
Not work because we need to pass it forward.
All right. So this is well, there is a difference between this and this. Okay, the previous will actually copy the memory in a new location and then act upon it.
So by value versus by.
Correct. So it's.
You can consider. You can't add to a vendor. You can consider the receiver to be another parameter. So it cannot do anything special parameter putting, which means you have to pass a pointer if you want to edit the receiver.
No, but this actually, I understand this. But previously you said the documentation said dev null was one of the variables exported. Is that correct?
No.
Yeah, it was just
in
a part.
its IO
Instance of
util.
it. Yes.
Yeah.
Right, it's an instance of it. But in the source code, it's saying fun dev null, so it's actually changing the object itself, not the class of the object. Is my question.
Okay. Let's step back for a second. We have types and we have values.
Yes.
So that's instead of classes and objects.
Sure.
It's relatively the same thing. What you're doing is in effect modifying the class, modifying the type to include a function.
Yes.
You are not modifying the value to include a function.
To extend.
Right. The value has whatever methods its type has.
So, okay, in this case, is dev null is a
Dev null
type.
is a type, yes.
Not a
Dev null is a type, yes.
okay.
And exactly, it's just an int.
And dev null.
Oh, okay. See, I missed that one line. Now it makes sense.
Okay, so this is 0 and this cast 0 to dev null.
Right. Okay.
Okay, so that it changed type and it's not anymore int. Has like the state of an int is like 1, and then sets the variable. Okay, this is they doing a trick over here. Okay, what we want to see is this one. We are setting the variable discard, that is the main example, has as an IO writer, and it allocates with a dev null that implements a IO writer. Okay.
No, no, that one line actually explained everything.
Now, what it is doing here is just asserting at a static type, a static when it's compiling the program, that dev null also implements reader from. Okay, so this is a special name for a variable that means ignore it, ignore the result. The most common use of this is for errors, as I see in most of the code. But what it's saying is,
People use it for ignoring errors and then wonder why stuff isn't working.
yeah. And then what it does is allocates this variable. It says it must have this type, and then it's trying to cast dev null to this interface. So basically, it's kind of an assert. Dev null has to implement reader from. Okay, just for consistency of the library. The library will
So is
type
underscore
check.
a real variable or just a placeholder?
Say that again.
Is underscore a real variable or is it a placeholder?
It's a placeholder, but I'm not sure. I don't think you can actually use it, right?
You can.
Okay.
That's the design.
Yes.
Yeah, but in some case, like $_ in Perl is an actual variable versus Erlang underscore is
So in Go, unused variables are a compilation error.
Mhm.
So if a function returns something and you want to ignore it,
Yeah.
you have to use underscore. There's no other way. It won't compile.
For example, like something like this. I'm just declaring a variable. It will barf. The code must be clean. Even with imports. Like if you're not importing. Okay. Let's come back where we were. Okay, discard. This is an example, of course, you already will understand that I'm reading the file. I'm using this other handy util from OS that will expand the environment variables. So you can put, for example, home. We will see another way of getting the user home shortly. And then I'm using IO copy on the writer, that's a utilities card, and wrapping the file with a new reader. Although I shouldn't have done this one. File implements already
Yes.
a reader interface, so I can simply do IO copy the writer and the file. Now IO copy is very useful. Any writer or any reader that you want to transfer from the reader to the writer, just use IO copy and we'll take care of it for you.
And that includes sockets, which is really nice. Yeah, you want to pair two endpoints and don't care what's going on there. You copy from one to the other and the other way around.
If we have time, maybe we code it live, something like that. It's very easy. And you can also compress, send it, uncompress, save it. That's the power of interface done right, in my opinion.
It's heavily based on Unix pipes. You can set up a complicated pipe system where it'll open a file, decompress it, take only a certain amount, and put it in a file, all in one really complicated pipe system.
Okay, next.
And then you can tee it so that it also does a hash for you, an MD5 hash, while you're doing that.
There is another, I didn't put an explicit example, but there is another utility that inside IO that is multi-writer. So you write to this method, and it will write back to multiple.
It's a multiplex.
Writer. It's a multiplex. Yes. Thank you, Mick. Here are some utility from file path and what we already saw, expand env, that just for file path manipulation, if you want to access the file system, are always handy. Other things from OS is OS args, that gives you the arguments that you pass to the program, and it's just a vector, an array of strings, and then.
Although there is a package called flag for passing command line, which is usually used instead of just art.
Is more powerful, and then the standard in, standard out, and standard error. All these are implements the reader, standard in the reader, and standard out and standard error the writer. A nice little package that is inside is OS user, and this gives you the information about variables of the current or a specific user inside your OS. Home dir not always is the environment variable, right? So you want to use this instead of the environment variable. Other nice things that we're gonna see maybe in the future is like you can know the host name of the system you're running, create pipes, start processes, all the batteries included, like we say with Python. Other nice thing for path / file path is clean. This will remove all double dots, end of slash. It will normalize all the path. Glob is what you expect if you want to have a list of all the Python, and walk will traverse your directory structure.
When you run clean, does it imply the current context, or does it translate everything to an absolute path?
I don't think it creates.
What is the question?
When,
if you
when you run clean, does it give you an absolute path?
It does not give you an absolute path.
Okay.
It would not know what the context is.
Just share this one to in the Google Hangout, and then I will create. And then see, import path file path, right? Was it path file path? Yes. And then we want to file path clean. Oops. So, for example, we remove this one. Let's see if I add
let's do that.
then some. Then I go back in some, and then I get out. Yeah. Okay. I'm sharing this on the Google Hangout, so others can play. Okay, what's next? This is something that gets. I think it got me. I was searching for a function. Like, I come from Python, and we have path exists. There is no such function in the standard library. You have to code it yourself with something like this. Path exists, and we use OS stat for it. So I guess because the guys are Ken Thompson and Rob Pike are hardcore Unix programmers. So I say this is the file path exists. You don't have to go create another one. There is an explicit error for it. I say is not exist. So that's handy. But basically, template this function and put it in your toolbox. Okay. So this is buffered I/O, and we use buff I/O package, and you can create a buff I/O reader from another from anything else that creates a I/O reader. In this, and why you will do that? You will do that because buff I/O provides additional methods on top of the simple write. One, for example, is read string. See if this runs.
It's also faster than syscall every time you read one byte.
So you want to read everything in a buffer and then read it more sequentially from it. This is pretty straightforward. We're using the standard int to read from it. And you can have other handy function like you can pick. That means you can read, you can see what's inside the buffer without actually consuming the buffer. Or like you can read the byte and put it back. You can see it has many other handy utilities that we can use. Okay, this is a caveat. Okay, buff I/O reader is not the same of. It's a different type from IO.reader. Okay, so this is type reader abstraction and implements IO reader. Okay, even if they have the the name is the same, but like the whole name is not the same. But those are two different types that implements the same interface. one tricky part of the buffered part is that you have to flash, as good manners, always flash. And we can see here, this is without flash, okay? So what I'm doing here, I'm reading from, I'm creating a writer using standard out. I'm using the package time.tick. This basically gives me a channel in practice, but it will return control to this function every second. Okay, every second is gonna give me a signal over here. We'll say blip. We can see it in practice, but for some reason we are not seeing anything, right? Like this system is running, and but we are not seeing anything. Why? I think we are not seeing anything until the buffer fills up. We need to actually flash every time we write something to actually say something. And there is tick, tick, tick.
Time.tick, what it does is it returns the current time every interval over a channel. So C is a channel, and a for loop, when you give it a channel, will continue to eat from the channel until the channel is closed or the program exits.
Okay, what's the error here? It says compile and define value and define value. So I didn't declare value anywhere. But you can use this assignment operator. This will create a value of this name with the value with the type on this right side. Okay, so you don't have to declare anymore the type. It will auto infer what's the type. But you can't create a variable with the same name twice. So we're gonna do a value that's only valid in this scope that will store the time that we get from tick. Let's see if this works. Cannot use value.
It is in a string, so you have to use format.fprintf. Although I'm not sure if you imported format.
No, unlikely import format. I can just write.
You need something formatted as a string or byte.
I think write. Let's see.
Time doesn't have a string representation.
Oh, yes, just dot string, right string.
Right.
String. Thank you. Yeah, dot string is dot to string in Java.
We want to make sure you guys are paying attention.
Mm-hmm.
Yes.
And there you go.
Mm-hmm. Slash.
Oh, yeah. Yes. Okay. Let's see what's next. Yeah, this you can do the same thing that you do with close, but with flash. Okay, so write and make sure to flash before you get out of this function.
Do the defers fire in the order that they were called in the function?
Reverse order.
Reversal.
Yes. The last one is executed first.
Reverse order normally makes sense. Normally it's to close, clean things up, and you normally clean up the stuff you did later. So.
So it's basically pushing it onto a stack, and then it's popping the defers off the stack.
Pretty much. and the arguments to functions are computed at the defer. So if you defer a variable, it computes that variable then.
When it's in the code or when it's executed?
It's when it's called, the
When-
defer is called.
When the defer is called as opposed to when it's executed.
So here I'm gonna do 1 plus 1, okay? So this it will is any error? So this will evaluate before actually calling the function. Okay. Right, but I have to extend. Let's see. All right. That's all right. I
yeah.
can read anything.
Reverse order.
Yep.
So defer is a keyword, you said?
Yes.
Yes. Okay, and you see, like it has been. You can actually see here been evaluated.
Mhm.
Before.
Yeah, that's actually an interesting thing to have the call sort of there and then have a defer in front of it and not have it execute immediately.
It's the same thing.
Because
with the
if
code.
I see that and not have your explanation, I would think call me 0 would be executed and then the result of that will be deferred.
It's the same with the Go keyword, which spawns a Go to. It's the same thing. You need to have actually a function called with parameters after the Go.
So you don't have to wrap it in another like lambda or something.
Yes. Okay, now this is another package and it's bytes. Do not be confused with buff.io. I get confused pretty often, and bytes is for strings and bytes. So it's creating a reader and a writer out of basic bytes and string. Okay, while buff.io creates out from other reader and writers.
It's in-memory files. Something.
There is string buffer in Java.
Yeah, string.io in Python.
What else? I don't remember anything else. Okay. So here is a little. What's wrong with this code? If I run it, it just exits without doing anything. Let me put it a bit bigger. Let me give it some time.
Does OS X not already have a writer?
Say that again?
Never mind.
You didn't flash F.
F. Huh?
After W.
F cannot be flashed.
I'm not flashing in there.
Why? It's STDR.
Standard out.
I mean, inner needs to be flashed.
Yeah.
But why are you flashing?
Okay, let's test.
But yeah,
F not used. What?
You call W twice. W twice.
Oh, right. All right.
There is no F flash.
Oh. Who's this guy?
There is no F flash.
Like, flash
So,
and define. So which one was the other suggestion?
Inner.
Inner. Like this. which one do we have to flash first?
W.
Let's see if this works like this. Yes. So, although I think we should flash first inner, right?
No,
W first.
because you're writing to W, and then inner is wrapping around W.
No, inner is wrapped by W.
Or rather, yeah. So you have to call W first and then inner.
Or you can just put these flushes as defers and then into defer.
Oh, yeah. So is defer
So this is
scoping thing or only in function?
only on the function. So what we want to do is we create inner, and then we make sure that we create W. We make sure that we flash, and then the same thing
Don't do that.
with inner.
And that's why the
That's
reversal doesn't make
interesting.
sense.
Okay. So in this way, like these are little toy programs. When you're gonna have your super concurrent mega web service, and it's not writing to the clients, and your boss is hammering on you, why it's not working?
Well, uh-oh.
Uh-oh. Inner flash, defer flash. This is not working. So we have to manually.
Why?
It doesn't make sense.
Oh, because you've already closed STD out,
Oh,
and
you
then
close-
the
you close
first.
Yeah, you need to defer the F close.
Exactly.
Way in the beginning.
See, this is. Where are we? Here. Ta-da!
Very nice.
So it doesn't actually tell you that you're trying to flash the closed.
Maybe there's an error.
Uh-huh.
Return to
Oh,
flash,
because you're
but
not checking.
Nobody's checking.
Right. Okay. That's interesting.
Yeah, W dot right string. Right string has errors, and that is where you will find all of your problems is missed an error
Mm.
that you're not
But
checking.
even when, would that, if that wouldn't be where this error is if we put the F close at the end though, right? Because the error would happen when you're defer when the
Yes.
defer runs.
Right.
So
string.
where should you be checking?
You should probably then wrap the defer in some function that
does
does the flash and check
I
it.
see. Okay.
yeah. I mean, flush, I guess, is returning
Right.
error.
But using the defer like consistently, it should get you out of trouble
Yeah.
most of the time.
And,
And always check the error returns error.
and we love returning errors.
Mhm.
So a lot of times you break in the middle of what you're doing to return the error, and there's the first still run. So the old concept of one way in, one way out for a function doesn't really apply in Go.
No, it's like a fine line.
Right.
It's more localized to where you actually want it to happen versus shot somewhere at the end.
Right. It captures the lexical.
And finally, what happens is that sometimes you need to do if this is not none, then close it. If this is not none, then close it. And the first, you do them only after you know that it's already created and good, so you don't need to do the check.
Okay. Yes. There is also another thing that some people get bitten by, and is you want to read a buffer, and you want to use this function to make sure that you read everything as you fill the buffer before returning it from the function. Okay, now another, just to have more, a bit of fun with these readers.
The reason read full was necessary is because when you read can return however much it wants up to the max, whatever buffer you sent it, and then it tells you how much it read. So if you don't use read all, you won't get an error, but you still might get less than you expected. Read all will just force it to be a no.
Okay. Okay, this is an example of how we use gzip to compress a simple string in this case. Okay, so we have this string text. We allocate our buffer buff of type bytes.buffer. This, by the way, create actually the buffer. Buff is of that type. And then we gzip using a new writer and using a buffer that implements a writer, IO writer interface. Okay. So this one will be writing on inside buffer, and then what we're gonna do is okay, we create a new buff IO writer for the zipped.
Who's the ampersand doing?
Where is it?
It's a pointer.
Oh, there it is.
Oh, this one, yes.
Yeah, so
The asterisk is for dereferencing. The add is for referencing. It's that's in the address.
Oh,
At creates a pointer, asterisk. We believe the opposite, yeah.
But you can't do pointer arithmetic.
Not without unsafe. You can import a package named unsafe, and then you are allowed to point arithmetic. You are allowed to arbitrarily point to memory and say it's a certain type.
Mm-hmm.
All that fun stuff.
Arbitrary execution.
Yes.
And like, if you don't want to support that, let's say you want to have, sometime you want to have a sandbox, sandbox context where people can't mess around for scripting, for web context. You just remove unsafe from when you compile Go. So you go and you remove that particular package, and basically you sandbox in that way.
you need to also remove the imports.
There must be some other. I never actually tried, but I think it's
We're removing CGO, which by default it's not there, right? So that's pretty easy. Remove unsafe, and you have to make it run single-threaded so that people don't
spawn
use,
too many resources.
yes.
So
And
well,
exec
well,
probably? Or their start process?
well, I mean, there are a ton of stuff you need to zero off. The playground, God only knows, I think they probably implemented their own version of the standard library pretty much.
I think one way I think
The playground is open source.
yeah, like you just
Yeah, the playground is part of the Go distribution.
No, the sandbox version isn't.
Oh, it's not?
Yeah, they've got a different one for a local machine that can do anything.
you can write the Go format script that will just delete a bunch of functions, right? Okay, let's keep it going. So what we're doing here is we have a memory buffer. We create a zip writer to the memory buffer. We create another another writer on top of the zip buffer, and this is a buff IO. So we have this nice utilities like write string. Okay, and we want that because buff zip doesn't have anything like write string. It has only write. Okay, you don't want to iterate over the string and cast and write. So we just have this nice handling function, and of course we flush and we close. Although, as you already know, this should be more like this, right? There. here.
Well, what's the reason for putting the verb up, right?
Oh,
Yeah, you probably just press enter.
where?
There.
Oh no, this is just this type. One like this. The other one will not compile. And this same example will do the reverse. So here we put everything inside inside buff. Basically, we wrote this string and it will get compressed and will go all the way up. Oh, that's the reason why I didn't do defer here. More in a second. And here we do the reverse. We create a reader from the memory buffer. We check, of course, for the error. This is a simple utility that will just do OS exit if the error is not needed. Okay, and then we create a reader out of the zip reader, and then we read our string. And as you might expect, this should be the same of this one that we inserted at the beginning. So we insert at the beginning this string. It goes through two writers. It gets compressed, puts in a memory buffer, and then we create out of that same memory buffer. We create a reader. We create a gzip reader, then a buff.io reader from the gzip. Then we do a read string on the buff.io reader. And this is and we print what we got. So a complete loop work. Now I don't know if I say it later. One thing is you have to close the gzip writer to actually be able to read it from. Okay, because so basically gzip when it closes that adds the gzip header information. So you don't want to do differ in this specific case. Like we should refactory actually put it in a nice function and then do differ in that function. I'm telling you this so when I'm gonna put these slides online. And these are all like a runnable example. You actually can run them from the console. Whoa. All right. Any questions so far? Okay, this is a fun one. Encoding binary implements reader and writer for a streaming operation, for how you can say, like low level types. Serialization, exactly, that's what's in common. And this is the interface of the read function, and it takes IO reader interface. You can specify the byte order of the data stream that you have, and that means Little Indian or Big Indian. And then you can say read this type from it. Pay attention at this type. What is this? Interface. That's a special type in Go, and that means an interface that doesn't have methods. And that means that any type implements that interface.
Mm-hmm.
Okay? And that's basically your base object for Java. One way to use it, let's say we have a float 32 and we read the Big Indian from and store the value inside F. Okay, basic like a scanf, you can say this one. but using big endian. But one nice thing that you can do is, because this is an interface, you can actually read the entire structure from a data stream.
You can. Does that work?
Yep.
Oh.
So this is.
Oh, okay. Okay, I thought you were passing a structure. You're passing.
Yeah, I'm passing val. Val is the type. Val is a variable of type struct.
No, it worked. They did a lot of work to make structs more aligned the way.
Imagine
You think it's normal.
Imagine if you have like a data frame from TCP, you can pretty much do this on the data frame with some.
Although there's a package called Go, which is a bit nicer than doing that.
You have to read the entire buffer in the same little Indian or big Indian.
Yes,
You have
probably.
the entire buffer has to be the same type.
Yeah, most likely. Otherwise, what you want to you want to read the two different, convert to one, and then extract the structure. But I don't think would make much sense. The structure in it.
There's a specific reason I didn't discuss. The shape files for like UIS, they're all written in mixed Little Indian, Big Indian. So if you wanted to read those, you would need to do some.
Yeah, you need to do additional, especially because you can't like read half of the struct and then the second half you don't have any pointer kinetic point in the middle of the struct. So you need to do some.
Although there is, I think I remember you can say read with this little Indian this method, and then you switch and you say big Indian and read another thing. I remember I saw something and that say and wondered. This is a nice link on Rob Pike saying like a rant about big Indian and little Indian. In my opinion, was nice. What is it? Goland. Then we have name again? Encoding.
Is it Indian data input stream?
Encoding, and then we have and then let's see. I thought it was okay. Now my fault. I thought I remember you can do, but no. Like it seems you have to switch it back and forth. Okay.
Can you see that?
This one?
Just looking. Can you run it?
Yes. So it's casting this one to B.
When you're printing it, I don't see the value.
No.
Okay, there we go.
Okay.
So just when I was doing PLC stuff, I would use
Was it PLC?
programmable logic controllers.
Oh.
Okay, well then you have to do this exact thing.
Talking world like
Talking crazy. The original protocols were written before TCP, so they have their own crazy architecture that they overlay on top of TCP, on top of DF1, on top of.
So this is a nice, handy information trick. Printf, if you do %v, it actually prints all the information, only the values of the struct. But if you add a sharp in front of the v, it gives you the type and the values associated with each one. So this can be useful for like debugging routines. Although we're gonna do a talk about how to use GDB with Go. You can use the full GDB with Go, and you can also use like other tools for that interface with GDB to debug Go. Okay, encoding binary. Well, that was my first introduction. Yeah, more or less on time. Now, as I say before, I want this meetup to be actually like hands-on. So I want now like to have our last 40, 50 minutes here to actually try to implement something, and we can help like do some of these small programs to do. If you want to have ideas, I think one idea that I always had in mind is to rewrite core tools, core utils. Okay, so these are written in C, and like you need automake, auto tools. You only know what to actually have this basic function. But in Go, it will be all static compiled and will be ready to use all the time. So I don't know, like you guys can choose one of it and like try to code and see if you can go through with the exercise. You can do.
LS is already there.
Where?
LS is already there, isn't it the walk or blob?
It's a blob.
Yeah, blob.
Yeah, well,
Yeah, but like
Something like
one thing.
Maybe yourself, yeah.
Yes. Okay, we have one.
These are
What's your
all
name again?
creative.
What's your name again? Farid is gonna go with the LS, and then I don't know, like CP. CP is, for example, one good for using IO copy, right? So each one feel free to use.
Also
Which one?
Cat.
Cat is actually the full implementation of Cat is
Yes,
it's not
I
that
can
easy.
imagine.
With all the
Yes,
with all the flags.
are very,
Yeah, with all the flags, and the fact that Cat can get several files and do them like.
Okay. So you guys prefer like coding yourself, like spin up your editors and see what we can come up.
We talked about base 64 when we came in. We talked about base 64 when we came in.
Base 64, yes, there is.
or making an MD5.
Also MD5.
We have MD5, SHA-1, etc. in the standard lib, so
do you have
just
a?
have to make one hashed it using.
Do you have your power adapter?
You know, from the
No,
file.
sorry.
You need one?
Yeah.
From the file. It's like,
But I need the new one, the one,
Yeah, it's got to 10.
the thin one.
Thin one.
So I think I'm sorry for the Google Hangouts, but my computer is gonna die soon. I don't know if you guys have one. Okay. Oh. Okay. I will try on a MD5.
CRC
I want to be unique.
32 and 4 util.
Unique.
Say it again.
There's CRC 32 and 4 util.
It doesn't have a UE at the end.
Unique.
Unique. Yeah. Sure. Sorry.
that one sounds interesting. You have to read in line by line.
You can read the next line.
Right.
Yeah. That sounds like a fun one. I tried to do this, believe it or not.
Do it in a hash.
What?
Do it in a hash.
make each line be the key, and then
No, because I need to preserve sort order. No, honestly, where I got stuck was in the flags